So today we are going to talk about collaborative filtering and the way that it works. Recommendations based on our requests, like recent links we click on, are now used everywhere. They are used in all social networks like TikTok and Facebook, search engines like Google and Yandex, and online stores like Amazon. These companies develop algorithms to track users' interests to create individual recommendations for them. On the screen, you can see everyday examples of recommendation systems. On the left, there's Boom, music app that creates a playlist with songs similar to what you listen to. In the middle, there's Instagram, social network that suggests posts similar to what you have liked before. On the right, there's Wildberries, online store that recommends products similar to what you have bought or viewed before. So, what is a recommendation system? Next slide. A recommendation system is a set of algorithms that predicts what users might be interested in. In the old days, the most popular products were recommended to everyone. As you can see on the slide, on some web pages like in Google Play, it exists up to this day. However, now users usually are recommended products that they will like with high probability. So how are those products chosen? Collaborative filtering, which you can see on the next slide, is technology for predicting user preferences. It's one of the oldest and most popular types of recommendation systems. System analyzes data about users and makes recommendations. Recommendations consist of things that other people with similar interests liked. System assumes that if users share interests, they will like similar things. On the next slide, you can see the meaning of the name, in which many people are interested in. Collaborative here means cooperative, because the system compares users with each other. Filtering in this context means predicting. System compares users to find similar users and predict the best products for them. In the next slide, you can see the typical workflow of a collaborative filtering system. First, users express their preferences by interacting with the system. Users click on links, like posts, view pages, and buy items. System remembers it and understands those actions as expressions of interest. Then, new user has the system find for himself other users with similar tastes. System compares that user's actions with other users to do so. System looks at items or themes that are interesting for similar users. Then the system suggests items or themes to the new user. Now we can provide an example from life. Let's imagine that we have three men, Gena, Vitya, and Oleg. Gena and Vitya like to go fishing and order pizza in the evening. They also both like BMWs and drive BMWs. Then there's Oleg, who also doesn't mind sitting around with a fishing rod at the weekend and ordering pizza after a hard day's work. But he has never thought about buying a BMW. Next slide shows that since Oleg's interests or grades are the same as those of Gena and Vitya, we can recommend him to buy a BMW. So on the next slide, we will consider how does it work. We have mentioned looking for similarities between users multiple times, but how do we actually get the numerical expression of this similarity of users? Let's say we have M products. The evaluations given by a single user represent a vector in M product space, and we know how to compare vectors. Now we can see on the slide possible measures of that. Cosine measure, Pearson correlation coefficient, Euclidean distance, Manhattan distance, and more. We will focus on the cosine measure for two vectors as the cosine of the angle between them. On the next slide, we can see cosine of the angle between two vectors, which is the scalar product divided by the length of each of the two vectors.
So about the algorithm of collaborating filtering, let's say we have a recommendation system with only 4 users and 4 films. And on the screen, you can see the table with grades users gave to films. As you can see, user Nastya hasn't watched the Deer Hunter film. Now we are going to watch step by step how the system uses collaborative filtering to say, can be the film Deer Hunter be recommended to Nastya or not? So we need to calculate how similar are the users with Nastya. So we will start with the first user. First, we need to find the cosine measure for two vectors. It's the cosine of the angle between them. So let's present their grades to the first 3 films in vectors, as you can see on the slide. And in the numerator, we put a a scalar product of grades. We take grades of Forrest Gump from both users and multiply them. When and do the same with grades for The Godfather and for Pulp Fiction. In the denominator, we put the length of both vectors, and to find it, we can look at the rows of grades of both users. And when we calculate the cosine measure and get the result 0.46 if we will round it. The same we do with the second user and the third user. And now we will finally calculate the grade that Nastya will most likely to give to the film Deer Hunter. We will use calculate measures during the process. So again, in the numerator, we put scores that other users have gave to the Deer Hunter and multiply it by the cosine measures that we get before. And we can see that user 3 is mostly correlated user with Nastya's because he has a higher cosine measure. So in the denominator, we put the product of two roots. In the first root, there is the sum of squares of the grades of all users. And in the second root, we put the sum of squares of cosines. And we multiply them. So we just normalize our score and multiply it by 5. And after the calculations, we will get that the possible grade that Nastya will give to the film, it will be around 4.97. And the result of such a mathematical example is that Nastya will most likely to give grade 5 to the film, and we can recommend this film to her. And now we would like to tell you about the recommendation system of our making.
Okay, so here we see our program. So for example, our group is 2011 or 211. So Simeon, how will you grade these singers?
Oh, so let it be 4, 3, 3, and 1.
Okay, so here you see your result. Some of them are not good counting. So, but there is your recommendation. Okay, do you want another one?
Oh, let's try, yes.
Okay. So here you see 4 D1.
So let it be 2, 2, 5, and 4.
Okay, there they are. So do you enjoy?
Simeon, do you like your recommendation?
Yes, pleasure one.
Pink
So,
Floyd,
yes.
Van Dorn. Instasanka is better than Zemfira.
Wow, it's a bit amazing, but yes, I generally liked, especially Pink Floyd.
Okay, Nastya, let's go new try. For example, we have next group. How will you grade this one?
Let's try 2, 5, 3, and 5.
Okay, you see Instasanka is the best and Van Dorn is the worst. Do you enjoy it?
Yes, it seems like very nice recommendation.
Okay, do you want another one?
Yes, if you please.
Okay, there are.
Let it be 4, 1, 4, and 5.
around.
Well, it seems pretty close to the reality. Thank you.
Okay. And Elena Yurievna?
Yes, I want to try.
Okay. Last group.
Okay, Lana Derley. I don't know her, so this is one.
One is the worst. So
Okay, this is 3. Okay, this is 3. Morgenstern, this is 2. Nerve 4, and Beatles 5.
So this mark.
Ed Sheeran, Rihanna, Elsie, Klava Coca, Alena Швед, Slava Merlo. Да, yes, I don't like Slava Merlo.
Okay. Another.
Yes, one more time. Oh, I don't know them. Oh, I really don't know them.
Okay. Maybe I can try to.
Try to put the
Right.
marks. Mhm.
Okay, I don't know him. 3, 4, 5, and 2. My recommendations are like this one.
Do you like your recommendation? You too?
Leningrad will be more in middle than the last, but it's
Okay.
cool.
Okay. So it seems it good works quite good for such a simple thing. Great, thank you very much.